Hello everyone. Today we're going to be reviewing linear functions. Now, a linear function is a function that represents a line, hence why it's called linear. Linear sounds like line. Now, when we normally think of linear functions, we remember y equals mx plus b, where m represents the slope and b represents the y-intercept. That's why it's called slope-intercept form, because you need the slope and you need the y-intercept. Now, when we are trying to find the slope is represented as the letter m, we think of rise over run. Rise is how the line is going up and down, and run is how the line is going side to side. Now, rise over run as a formula, we could also remember that it is the change in y over the change in x. That little symbol, the triangle symbol, that just means change, represents change. Okay. This right here, the change in y over change in x, that's slope formula, which we would need to use 2 points. And it could be, we could find the slope by doing y2 minus y1 over x2 minus x1, meaning that we're going to subtract the y values to get the change in the y's, and we're going to subtract the x values to get the change in the x's. And this would give me my slope. Now, to find the x-intercept is when your line or any function touches the x-axis. Now, if you look at the x-axis, okay, when you go across it, if you were to name some coordinates, we would have -2, 0, -1, 0, 0, 0, 1, 0, 2, 0, etc. The only thing that's changing are the x's, but the y values all stay the same, and they are all 0. Therefore, if I ever need to find the x-intercept that's not on a graph, meaning that I don't have a graph for it and I can't just look at it, we would take the equation and we would plug in y is equal to 0. So now it works the same way with the y-intercept. The y-intercept is when a function touches the y-axis. And if you were to go up and down the y-axis and name some coordinates, we would have 0, 0, 0, 1, 0, 2, 0, 3, etc. What's always consistent along the y-axis is that x is 0. Therefore, to find the y-intercept, we would plug in x is equal to 0. So now that we kind of have these basics reviewed, let's take a look at this example of a line. If I wanted to identify the slope and the intercepts of the line, we're going to just have a look at it. Let's start with slope. When you're calculating slope based on the graph, we need to pick 2 points, and it does not matter which 2 points you choose. So I'm going to go ahead and choose this one here, which happens to also be my y-intercept. This is 0, 2, and then I'm going to choose this one right here, which is 4, 0, which also happens to be my x-intercept. So now that I have these 2 points, you can use your slope formula, right? Because this would be x1, y1, and then this would be x2, y2, and then just apply the formula. However, I can also just count, right? If I want to find the slope, I want to see how does it move up and down, and we're going to divide it by how it moves from left to right, from one point to the other. You can either start from the point on the left, you can start from the point on the right. It honestly does not matter. So let's say I start with the point on the left. To get from this point to this point down here, I am going to move 1, 2 units down. So since I'm going down, that means it went -2 units. Okay, whenever it goes up, that would be positive. If it goes down, it would be negative. Same thing for left and right. If you're going left, it's going to be a negative number, and if you're going right, it'll be a positive number. Now I'm going to count how many units does it take to move to the right. Again, since I'm moving to the right, that's going to be a positive number. And from 0 to 4, that is a total of 4 units. Therefore, my slope, rise, that's the vertical change, which is -2, divided by 4 units to the right. So -2 over 4 can be simplified to be -1 over 2. So this is my slope for that line. Now you always got to check, does this slope make sense? And if you think about it, right, if you have a negative slope, that means the line will go down as you read it from left to right, meaning it's decreasing. So this does make sense. If you had gotten a positive slope, that would indicate that your line was increasing, meaning as you read it from left to right, it would go up. So now I have my slope. The x-intercepts and the y-intercepts, well, that's what I use to calculate my slope. So x-intercept is 4, comma 0. Remember, intercepts are coordinates and should be written as coordinates. And then our y-intercept is 0, comma 2. Now, important to note that the y-intercept, which is the y value, this is b in slope-intercept form. Since I have the slope and I have the intercept, I am actually able to write its equation. Remember, it's y equals mx plus b. All I'm going to do is I'm going to replace m and b with its values. So the equation of this line would be y equals -1 over 2 x plus 2. Now over here on the right, I have some other forms of linear equations. This first one is the general equation of a line, which is ax plus by is equal to c. A, b, and c are just constants, or rather a and b are coefficients. So those letters just represent numbers. Okay, but what this means is that the general equation of the line is when you have your variables, x and y, on the left side of the equal sign, and then whatever number that does not have the variable will be on the right side of the equation. Now, typically, we are not going to leave our answers as a general equation, but we will see it, so I put it here. Now, point-slope form we will be using pretty often, and it's actually a stepping stone to get from whatever information is given to us into slope-intercept form. Now, point-slope form, we're going to need, guess what, the point and the slope. Okay, the names of these forms actually tell you what you need in order to use it. Just like slope-intercept form requires to use the slope and the intercept, point-slope form means you need a point and a slope. Right, so slope is always m. Then our point would be here, the y1 and the x1. This is where you would plug in your point, whereas you would leave the y and the x all by itself. Now for vertical and horizontal lines, most students typically get confused with how to write the equation of a vertical and a horizontal line. So I put here as a reminder. Now I wanted to explain as to why vertical lines are written as x equals c, where c is a constant. Okay, so I'm just going to write this here, constant. Okay, now I'm going to explain why it's written as x is equal to c. I'm going to use the graph that I have here just because, it's there and we can actually see the vertical line and it'll help me with my explanation. So it's unrelated to that particular line, but just so you can see. So here we have some vertical line and I want to write its equation. Okay, so let's say I was to write down some coordinates, right? I have, this would be 2, 0. This coordinate here would be 2, 1. This one is 2, 2. This is 2, 3, etc. Right, well, there's only one left, so 2, 4. If you look at these coordinates, there's one thing that all of these coordinates have in common, and that is that the x value never changed. So that's why the equation, let's say, of this line would be x is equal to 2. That's why all vertical lines are written as x is equal to, and then whatever x value it happens to go through. For horizontal lines, it's the same concept. If you were to draw a horizontal line, the only thing that would remain the same across the horizontal line is the y value. So we would look at what the y value is of the coordinate, and that would be the equation of the horizontal line. So now first thing that we're going to do besides reviewing our linear equations is we're going to look at now equations versus graphs and find out what is the slope and what is the intercept. So as a reminder, remember that most equations of lines are written as y equals mx plus b. Now all of these here are not written y equals mx plus b, but this one is. Just by looking at it, I already know two pieces of information. I know what my slope is, because that is your m, and I know what my y-intercept, because that is the b. So right here, we have the y-intercept, which is, remember, a coordinate. So the actual value is 12, but the x will always be 0. So that's 0, 12. Then your slope, which again is here, right? It's your m, is 3. All that's missing is to find the x-intercept. And from the previous slide, we saw that in order to find the x-intercept, you need to plug in that y is equal to 0. So where the y is, I'm going to replace it with 0. So 0 equals to 3x plus 12. Now I can use this equation to solve for x. So I'll subtract the 12 from here and move it to the other side. And we have 3x equals negative 12. All I did was I reversed the order. I like to have my variables on the left. But if you wrote negative 12 equals to 3x, it's the same thing. So now your final step here would be to divide by 3. And this would give me that x is equal to negative 4. This is the x-intercept. But again, we could write that as a coordinate, which is negative 4. And remember, I plugged in y is 0, so the y is 0. So those would be my intercepts and slope from this equation. Now if I look at this next one, we have 4x plus 9y is equal to 3. This should seem familiar, this form. This is the general equation of a line. Now the general equation does not give me any information. It doesn't tell me the y-intercept. It doesn't tell me the slope. So I'm going to need to rewrite this in a way that I can be able to tell some of that information. You can either choose to solve for the intercepts first, or you can write this in y equals mx plus b format. And if you do, that would give you your slope and the y-intercept. And then you would just have to solve for the x-intercept. So I'm going to do that first. I'm going to rewrite this in y equals mx plus b format. That means that I want to get this y alone. Now when you're working with equations, you're going to want to work from your outside in so that you can isolate that y value. This is the part that is farthest away, so I'm going to subtract this over to the other side. So my equation right now will read 9y is equal to negative 4x plus 3. Notice that I flipped this order, and that's because it's y equals mx plus b, meaning that the term with the variable x is written first. That negative is attached to the 4, so I put negative 4x, and since that 3 is positive, I put plus 3. To finish with this, to change it to y equals mx plus b, we're going to have to divide the 9. When we divide the 9 on the other side, you have to divide every term by 9. So now my equation is going to read y equals negative 4 over 9 x plus, and then 3 over 9. 3 over 9 can be simplified. Both 3 and the 9 are divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So this is my equation in slope-intercept form. So I already have two parts of my answer here. I have my slope, which is equal to negative 4 over 9. And then I also have my y-intercept. Remember, I'm going to write this as a coordinate. My y-intercept is when the x is 0, and then b, which is 1 over 3. Now to get the x-intercept, you're going to have to plug in y is equal to 0. Now you can choose to plug it into the equation that we just rewrote, the y equals mx plus b. But then you would have 0 would equal to negative 4 over 9x plus 1/3, which I know most of us don't like to work with those fractions. So instead what you can do is you can plug in x is equal to 0 in the original equation that has no fractions, and it would actually be easier to solve. So for my x-intercept, I'm going to plug it into the original equation. Now that does not mean that plugging it into the new equation is incorrect. You could still do it that way. I'm just always going to try to show you the easiest way possible. So for the x-intercept, we're solving for x, so that's 4x plus, and then we're going to put 9 times 0, because we're plugging in y is equal to 0, is equal to 3. Now anything times 0 is 0, so bye. And so my equation right now reads 4x is equal to 3. This is much easier to work with. All I have to do is divide by 4. And we get that the x-intercept is 3 over 4. So if I were to write that as a coordinate, remember it's the x value that we just solved for, so it's 3 over 4, and we plugged in that y is equal to 0. And that's my solution. I'm going to highlight my answers here so they don't get lost. This is my x-intercept, my y-intercept, and my slope. And then in this question, the same, my y-intercept, my slope, my x-intercept. Now moving on to C, we have y equals 3 times x minus 9 plus 12. Now this is looking like it's almost in slope-intercept form, so I'm just going to go ahead and finish it by distributing this 3. When you do that, you get y equals 3x minus 27, and then the plus 12, which we can combine like terms, and our equation could be rewritten as y equals 3x minus 15. Just like in part A, this equation is in slope-intercept form, so my slope is equal to 3, and my y-intercept is 0, negative 15. Now to find the x-intercept, you're going to go ahead and plug in that y is equal to 0. So we would do 0 is equal to 3x minus 15. And now we're going to solve for x. So I'm going to add the 15 over, and we get 3x is equal to 15. Again, I just reversed the order here, but it's the same thing as if you wrote 15 is equal to 3x. Divide the 3, and we get that x is equal to 5. Therefore, the x-intercept is going to be 5, 0. So here are my solutions. Just going to highlight that. Now this final one here, we have 3x plus 4y is equal to negative 8. Again, this is a general form, which much like in part B, so we can either write it as y equals mx plus b first, or we can solve for the intercepts first. Since I wrote it as y is equal to mx plus b first in part B, I'm going to go ahead and solve for the x-intercepts and the y-intercepts before. So that way to vary it up so you can see both methods. So let's say I were to solve for the x-intercept. That means that I am going to plug in 0 for the y value. So I'm going to take my equation, which is 3x plus 4 times 0 is equal to negative 8. Again, anything multiplied by 0 is 0. So now my equation is 3x is equal to negative 8. Your final step would be to divide the 3. So x is equal to negative 8 over 3, meaning that the x-intercept is negative 8 over 3, 0. Now to find the y-intercept, it's the same process, except we're going to plug in x is equal to 0. So we would do 3 times 0 plus 4y is equal to negative 8. Again, anything times 0 is 0. So now my equation is simply 4y is equal to negative 8. We're going to divide the 4. So y is equal to negative 8 over 4, which is the same as negative 2, making my y-intercept 0, negative 2. Now to find the slope, we will have to take that equation and write it in the form y equals mx plus b so that we can see the slope. Okay, so our first step would be to subtract this 3x so that way we can get that y alone. So if we subtract the 3x, I'm going to do it up here so you can see. Move it over here. We would get the equation 4y is equal, now remember, I'm going to keep it in the proper order of y equals mx plus b. So I'm going to write negative 3x minus 8. Then our final step here would be to divide by 4. Remember, you're going to divide everything by 4. So the line is y is equal to negative 3 over 4x minus 2. Notice that when we have this equation, not only did I find the slope, which is negative 3 over 4, but I'm also verifying my y-intercept that I found earlier. See how the b is negative 2, and it shows that in my y-intercept I got 0, negative 2. So this is also a nice way of verifying the solution that we got earlier. So here's my x-intercept, my y-intercept, and finally my slope. Now moving along, the next two slides, we're going to go ahead and solve for the equation of the line using given information. So for all of these, I'm going to give you all types of information. Sorry, I had some stuff on there. Okay. So we want to write the equation of each line in slope-intercept form. Again, that is the y is equal to mx plus b. Since you have to remember a lot of formulas and equations, I always write the general form every time I begin, so that way I never forget. So in this particular question in A, I have the slope of 3, so I'm going to write that down, which is m is equal to 3. And my y-intercept is b, so that means that I got b is equal to 8. I have m, I have b, I don't need to do anything else with this question. I already know that my equation is going to be y equals 3x plus 8. And we're done with that one. For part B, it says horizontal line passing through 0, negative 2. So now for a horizontal line, we have to remember how are horizontal lines written. Remember, if it's a horizontal line, let's say here is my axis, and I have this line here, and we were to go through these coordinates, the one thing that would remain the same along that horizontal line is the y value. Therefore, all horizontal lines are written as y equals and then whatever number the y is equal to. If I look at the coordinate, the y value is negative 2. Therefore, the equation of this line is y equals negative 2. Now for part C, we want to find the equation of a line that passes through 1, 2, and 5, 10. Whenever you're writing the equation of a line, you're either going to have to put it in slope-intercept form, like we did in part A, or we're going to have to go through point-slope form first before we can put it in slope-intercept form. Either way, the thing that you need in order to put it in any format is you're going to need to find your slope first. Now remember slope formula. M is equal to y2 minus y1 over x2 minus x1. Since I have 2 points, I can label these points. Doesn't matter which one you decide to label them as. I'm going to say this is x1, y1, and this is x2, y2. Okay, and now we're just going to plug it into the slope formula. y2 minus y1, so that's 10 minus 2 over, and then x2 minus x1, 5 minus 1. 10 minus 2 is 8, divided by 5 minus 1 is 4, and 8 divided by 4 is 2. So this is my slope. So let's evaluate now what it is, what information we have. We have the slope, and we have 2 points. Because I have a slope, and I have a point, we're going to use point-slope form, which, as a reminder, is y minus y1 is equal to m times x minus x1. So we're going to pick a point. It doesn't matter which one because you can't use both. I'm going to use 1, 2 since it is, I don't know, cuter numbers. Okay, and then we have the slope, which is 2. So I'm going to plug in the y value for y1 and the x value for x1. So when we plug it in, we are going to get y minus the y value, which is 2, is equal to the slope that we found to be 2, times x minus the x value, which is 1. From point-slope form, there are 2 steps to take in order to get it to look like y equals mx plus b. The first step is to distribute. Okay, so I'm going to distribute that 2, and I'm going to get y minus 2 is equal to x minus 2. Then the last step would be to add or subtract whatever number is attached to the y. So in this case, I have that y minus 2. I'm going to add 2 to get that y alone. So my equation for the line is going to be y is equal to 2x, and then negative 2 plus 2 is 0. So it's just y equals 2x. And that would be our equation. For part D, we are told that we want to find the equation of a line that is parallel to y equals 3x minus 4 and passes through the point 1, 1. Now we need to remember, what do we know about parallel lines? Aside from them running side by side, in order for them to run side by side, that means that they must have the same slope. So when we look at this equation, notice that this is in y equals mx plus b format. The slope of this line is 3. So that must mean that the slope of the line that we're trying to find will also be 3, because slopes of parallel lines are the same. So now, just like the previous problem, I have a point, I have a slope. That must mean that I can use point-slope form. So one more time, point-slope form, y minus y1 equals m times x minus x1. I'm going to plug in the point here. I have no choice. I was only given 1 point. So we're going to do y minus 1, that's the y value, equals to the slope, which is 3, times x minus the x value, that's 1. Remember our 2 steps. First, we distribute. So we have y minus 1 is equal to 3x minus 3. Then your next step, your last step, is to isolate the y value. So that means I'm going to add this 1. And now our y is going to equal to 3x minus 2. And this is the equation of that line. In the next slide, we're now going to practice a few more of these. Okay, so some of these are going to be a little bit more complicated. First, we have a slope of 3. So again, that's m is equal to 3. And it passes through point 7, 9. So we have a point, we have a slope. One more time, we're going to use point-slope form. So now let's write it out. We have y minus the y value, which is 9, is equal to 3, the slope, times x minus the x value, which is 7. Remember our two steps. We're going to distribute. So y minus 9 is equal to 3x minus 27. And then we're going to isolate the y by adding this 9 over. So our equation in slope-intercept form is y equals 3x minus 18. Moving along to part B, a vertical line that is passing through the point -2, 1. Remember, vertical lines, that is where your x value never changes. All vertical lines are written as x is equal to some constant. So for this particular line, we have a coordinate. I have to look at what the x value is since it is vertical. Since it is -2, that means that the equation of my line is x equals -2. For part C, we want to find the equation of a line that is passing through these 2 points. Remember that if you're only given points, you will need to find a way of finding the slope first. So we're going to apply slope formula. Remember, slope formula is y2 minus y1 over x2 minus x1. I'm going to label my points, x1, y1, and this will be x2 and y2. So let's see, when I find my slope, I'm going to do y2 minus y1. We have 4 minus -1 over 2 minus -3. Now it's important to note that when you are going to subtract a negative, okay, what I do is I normally just turn it into one big plus sign. Subtracting a negative means that it's actually adding. So here we have 4 plus 1, which is 5, over 2 plus 3, which is 5. And 5 divided by 5 is 1. Now that I have a slope and I have 2 points, again, I'm going to have to use point-slope form. You can choose whatever one of those 2 points you have. So if you're only given 1 point, you're going to have to use that 1 point. But if you're given 2, it doesn't matter which one you use, you can choose whichever. I'm going to choose to use 2, 4. It doesn't matter which one you use. So we're going to plug it in. Y minus 4 is going to equal to the slope, which is 1, times x minus 2. So remember, our first step is to distribute. Now, it's just a 1. We distribute a 1, it's just going to be the exact same thing, right? 1 times anything is just itself. So y minus 4 is going to equal to x minus 2. And then our final step is to isolate the y. So I'm going to add 4 to the other side. So my equation is going to be y equals x plus 2. Now for this final part, we want to write the equation of a line that is perpendicular to 3x plus 5y equals 9. And it's going to pass through the point 2, 3. So I have a point, and I want to know the line that is perpendicular to this one. Now for perpendicular slopes, okay, so this is the symbol for perpendicular. We know that M represents slope. Perpendicular slopes are opposite reciprocals. So let's say, for example, a slope is 2. The perpendicular slope would be -1/2. So you always flip it and you change the sign. So if I want to find the perpendicular slope, I need to first figure out what is the slope of 3x plus 5y is equal to 9. In order to figure out what is the slope of that, I have to write it in a format that will allow me to find the slope. So that means that I have to rewrite this equation first in slope-intercept form. So remember, we're going to take this right here, and we're going to make it into y equals mx plus b. In order to do so, I'm going to first subtract the 3x So that way I can start isolating the y. So at the moment, the equation is 5y is equal to negative 3x plus 9. Then the final step would be to divide 5. Remember, you have to divide everything by 5. So that means that the equation of this line is y equals negative 3 over 5x plus 9 over 5. I don't really care about everything else that's going on. This is what I care about. This is the slope of that line. Now, because we're looking for the perpendicular slope, the slope that I will be using for my line is now going to be positive because I got to switch the sign and find the reciprocal. So you're going to flip that fraction. So the perpendicular slope is going to be 5 over 3. This is the slope that I'm using along with the point 2, 3. And we're going to plug it in to y minus y1 is equal to m times x minus x1, which is point slope 1. So let's plug it in. So we have y minus 3 is equal to 5 over 3 times x minus 2. Remember, we have two steps. First step, let's distribute. I know that a lot of us see a fraction and we don't like it, but we're going to have to get used to it. So let's see what happens. When you distribute the 5 over 3 to a variable, it's just going to be that fraction with the variable. So the equation so far is y minus 3 is equal to 5 over 3x. Now 5 over 3 times negative 2, I already know it's going to be negative. Now when you're multiplying fractions, I'm going to do it in a separate color up here where I have some more room. Okay, we're going to multiply 5 over 3 times 2. Now if you're multiplying with the whole number, remember whole numbers are always over 1. And when you're multiplying fractions, you multiply numerator with numerator, denominator with denominator. So when you multiply this, we have 5 times 2, which is 10, over 3 times 1, which is 3. So right here in this space, when we distribute that 5 over 3, we get 10 over 3. Our final step is going to be to add this 3 over, so we can isolate that y. But now what happens? I have to combine this negative 10 over 3 with plus 3. Again, I'm going to actually switch colors here so I can do that separately. Okay, so I'm going to do negative 10 over 3 plus 3. Remember, it's over 1. When we're adding or subtracting fractions, we always need a common denominator. If you don't know what the common denominator is, you're not 100% sure, you can always just look at the denominators you have and multiply them together, and that'll work. 3 times 1 is 3, so the common denominator for these two fractions is going to be 3. So then you have to rewrite each fraction so that it has the same denominator. Negative 10 over 3 already has a denominator of 3, so we do nothing with this. But for 3 over 1, I need to rewrite it so that the denominator is 3. It just so happens that if I multiply this denominator by 3, that'll do the trick. But whatever you do to the denominator, you must do to the numerator. So now what I end up with is negative 10 over 3 plus 9 over 3, which gives me a negative 1 over 3. So this right here, this negative 1 over 3, that's this part. So now I'm going to rewrite my final answer. Our final answer would be y equals 5 over 3x, and then our new y-intercept, which is negative 1 over 3. And that's how you write equations of lines. Now this last bit is graphing lines. Okay, now I put some steps here for you so you can follow along in case you ever get lost later. But your first step is always to rewrite the equation in slope-intercept form if needed. Sometimes they're already written in slope-intercept form, such as the graph that you see below us. the line is y equals negative 1/2 x minus 2. This is already in slope-intercept form, so if I was going to graph this, I wouldn't need to do anything. So that would mean that step 1 is done. For the second step, you're going to plot the y-intercept. In this particular line, the y-intercept is negative 2. I'm just pretending as if I don't have this line here, and I'm graphing it. So that way you can see how we would end up with the line that's given. So this is the y-intercept, which is at negative 2. So that is plotted. Then we would use the slope to plot an additional point starting from the y-intercept. My slope is negative 1/2. Now, when you have a negative on the outside, that means that either you can attach the negative to the numerator, or you can attach the the negative to the denominator. It doesn't matter which one. Remember that slope is rise over run. So the first number will tell you whether to go up or down, and the bottom number will tell you to go left or right. If I were to use the slope with the negative in the numerator, so negative 1 over a positive 2, that means that from the y-intercept, I would have to move down 1, and since the 2 is positive, I would move to the right 2, leaving me right here at that point. If I were to use the slope written with 1 over negative 2, that means that I would go up 1 and left 2. And see how it doesn't matter which one I choose to use, I still end up on the line. Then you would just connect your dots and you're done. So for part A, we have 2x minus 5y is equal to 5. My first step is to rewrite it in slope-intercept form. So I am going to first subtract this 2x to the other side. This will leave me with negative 5y is equal to negative 2x plus 5. And then our final step would be to divide the negative 5. Remember, you're dividing everything on the other side. So when I rewrite this equation, my line would be y equals, look at the slope, we have a negative divided by a negative, which makes it a positive slope of 2 over 5x, and then a positive 5 divided by negative 5 is a negative 1. My y-intercept is negative 1, so I'm going to plot my dot at y equals negative 1, and then my slope is 2 over 5, so that means I'm going to go up 2 and right 5. Once I have 2 dots, that's all you need. You can go ahead and draw your line. And that's it. For part B, we have x is equal to negative 1, and you would need to figure out, okay, whenever you see the equation of a line where you just have a variable equals a number, that means that it's either horizontal or vertical, and you have to decide which one it is. Now, if you ever get confused, you're not sure, okay, I put here, when in doubt, plot the point and see which direction makes sense, whether horizontal or vertical. So I have x is equal to negative 1. So I'm going to go to my x-axis, and I'm going to plot a point at x is equal to negative 1. Let's say I thought this was a horizontal line. Well, if it was horizontal, and I were to plot a point over here at x is negative 2, that means x is no longer negative 1. That doesn't make any sense. So this must be a vertical line. If I were to draw a second point, let's say right here, this is negative 1, comma 2, meaning that my x value, no matter where I go along this vertical line, is still negative 1. So this is a vertical line. Now it's important to note, I forgot to mention this earlier, all vertical lines, if I were to calculate their slope, okay, I would have a change in y values, right, because it's going up and down, but no change in the x values. That means that if I were to find the slope, let's say if I were to use these 2 points, if I were to use negative 1, 2, and negative 1, 4. If I were to find the slope, it would be 4 minus 2, which is 2, over negative 1 minus negative 1, which since they're the same number would be 0. Remember fractions? You can never divide by 0. So this means that all vertical lines have an undefined slope. That means that for horizontal lines, will not have a change in y values, but will have a change in x values. So the horizontal lines would actually have slopes of 0 over some number. 0 divided by anything is going to be 0. So all horizontal lines have a slope of 0. So it's just a side note that you should always remember. Okay, and that's all.